So what I'm going to do now is we're going to combine the two different kinds of analysis of variance we talked about. So far we've talked about a simple between designs and simple within designs. When I say that they're simple, what I'm talking about here is one-way analysis of variance. So one factor, straight ahead analysis of variance. We've talked about it between subjects, and we just finished talking about it within subjects, even just the one factor repeated measures. We've talked about factorial between designs, you know, the classic A by B. And we just literally, moments ago, before that little bit about shake and bake, we're talking about doing, I guess it was what, a 2 by 3 within subjects factorial design. Sure. So factorial between and within. Well, of course we can combine them, or there wouldn't be a lecture today. So we're just going to combine these, you know, one between, one within. In fact, that's a very common approach. In fact, I'm hesitant to say most common, but a lot of papers you read have one repeated factor and one between subjects factor. So let's do it. Yay! That's why it has an exclamation point, because we're excited. Okay, why would you do that? Well, there are cases we might want one or more between and one within. Let's say we're comparing different species in their ability to learn. Learning is probably the classic example of a within subjects type of variable. We have to look at change over time. And we can't do species within subjects. We can't change species on the go. Not until I've developed my time machine. So, and I was just at a conference on comparative cognition. People compare species. It's called comparative cognition for a reason. And you'd see different species and their ability on learning. That's my whole, my PhD. That's compared to species in their memory. So it's a pretty common thing. Well, you might, let's say you're doing sex differences, or just any old group differences. Right? Okay. So it's actually there's a reason it's a pretty common type of design. So sex differences, these kind of things. Any kind of group differences. All right. So here's an example. And you guys in the psych lab course realized that we probably should have done our experiment this way. We did our implicit explicit. We should have had one group do the explicit memory and one group do the implicit memory, because it seemed like there was sort of a bleeding between the two different conditions. So like doing the explicit task, or doing the implicit task actually acted as rehearsal for the implicit task. It was annoying. For a brief moment, we all thought we completely blown the lead off all nuclear research ever. Then we realized we probably did it wrong. So what we do here is we've got one group, we're going to do an implicit task, word fragment completion, whatever, for 5 minutes, 1 hour, 24 hours. And one more group, we're going to do an explicit task. And never the twain shall meet. Nobody ever read a poem? No? Okay. East is east and west is west, and never the twain shall meet. Till some dotted man, something with some judgment thing. It's been a long time. It's grade 8.
It was going so beautifully.
No, I don't remember much. Like, I got little snippets. I can remember whole, scenes from Hunt for Red October or every Star Trek series, but I can't do classic poetry.
Who's the author?
I think that was Eddie Van Halen who wrote that. Dickens? It was Dickens. Dickens did the English movie. Did you read Dickens? You're probably right, because you know more about that stuff than I do. So you're the experts on it. It sounds like Frost.
But it might, I might be wrong.
Yeah. Is it Eddie Frost? No. Robert's brother Eddie is not so talented brother. I just sit there. Oh, see, some of this stuff I just edit out and I just let it go. Okay, there may be, as I said here, some concern about the implicit test being contaminated, or the explicit test being contaminated, which I think is what happened in the lab class. Fine, so let's just divide it into 2 groups. We still want a decay function, though, for the explicit, and we're not going to actually get a decay function for the implicit. It'll stay steady, but that's fine. Great. So, what are the sources of variation? Oh, by the way, this says group 1 is subjects 1 to 10, group 2 is subjects 11 to 20. It's like 3D. If they extra for that 3D in the TVs, but not here, look at that. It's coming right at you. That again was just for me, that was referring to Count Floyd's 3D as analysis of variance. See, for me, that's hilarious. That's one of those ones I'm telling my friend Mike. That we make jokes that no one laughs at and then we tell each other. I'll be emailing him right after class.
Does that mean that it's like subject 1 to subject 10 and then
Yeah.
subject 11 to subject?
That's right.
Okay.
Because I could give them all names, but I couldn't think of 20 names.
I was just reading it as a mathematical.
No, it's not that bad. No. Okay, so we got 2 things. We got test type, implicit and explicit. We've got retention interval, 5 minutes, 1 hour, 24 hours. And then we got to say something about the subjects, because they're a source of variation, right? Whenever we make those tables, think about, here we go, right here, right? We had A, B, A by B, and error, sure. So we're going to say something about the subjects. And if you think about it, remember it was like treatment, error, and treatment by error. They're repeated. So what we say here, we have subjects nested within test type. That's what the parentheses mean. And I think that's what that says there. Subjects nested within test type. That's how you say that. Or just subjects within test type. What that says is some subjects get one level of test type, and other subjects get a different level. That's all that means. Okay. Do you understand that notion then, that subjects are within test type? Okay, makes some sense? Okay. All right. So I'm going to go to the next slide now. Are you okay? Please.
On that table, across the line E with explicit, should that only G2s?
Yes. I made a mistake. Sorry, thank you for pointing that out. Yes, this should be G2, G2, G2.
Okay, that makes sense.
Yes. I'm an idiot. Thank you. I can't believe I missed that. I probably copied and pasted this from somewhere. From the old, or I'm lazy and stupid. And old. I'm old. What, old? Yeah. It works. We hope. You know. Okay. So now we're going to build the analysis of variance summary table, which is, the first thing you list is the between factor. Then the subjects, then the within. Between, subjects, within. This will tell you how to test what with what. This is called Yates' order. Developed by, discovered, I guess, correct? By Frank Yates, who was one of the people that developed analysis of variance along with Fisher. And Yates' order says the first term you list, the term below it with the subjects in it is going to be the error term. And it's between, subjects, within. And you should, one of those things to say to yourself, you'll be saying the rest of March, you'll be saying between, subjects, within. So, test. So test type. That means like implicit or explicit, because it's a between subjects factor, isn't it? Different subjects get different levels of test. So we list it first. And then we talk about, are there any other between factors? No. The other one's a within factor, a repeated factor. So the next thing we see is subjects. But we cannot just talk about subjects. We must talk about where they are. Subjects nested within test. So we get 18 for that. N minus 1, that's 9, right? So that's 10 subjects per group, minus 1 is 9, times 2 levels of test. 9 times 2 is 18. Now, are there any other between subject factors? Not in the design we have here. So, we do the within factor, which is retention interval, which has 2 degrees of freedom, because it's Ri minus 1. There's 3 levels of retention interval. We subtract 1. We got 1. Now, the rest is now easy. Ri by test, Ri by subjects within test, done. What do we test with what? If we're doing the analysis of variance, we're going to test mean squared. To find out if there's an effective test, we're going to divide by mean squared for subjects within test. To find out for both retention interval and retention interval by test, their error term is retention interval by subjects within test. This always works. The only time it doesn't work is if one of these independent variables is a random factor. If one of them is a random factor, your best solution is to just nuke the site from orbit. Aliens? No? No. The best thing to do then is go get a really good graduate stats book and have it work out the expected values of each source for you. There are cases where you can't, in SPSS, with the advanced version we don't have, or in other, excuse me, other stats packages, you can say when something's random and something's fixed. Oh boy, what the hell happened there, but it wasn't pleasant. Oh, I'm glad that didn't happen in my talk last week. No, it would have been fine. Everybody would have rushed up. You okay? No, I'm fine. Hip. By the way, the joke about in the white room with black curtains by the station, it killed. It's a joke I made, no one got when I did it for my classes, but people there got it. Know your audience. Okay, questions about that? Yeah, Denny, go ahead.
In the subjects test row, you have 18, knowing that there's 20 there. Why am I minusing 2 from it?
You're not minusing 2 from it. You're doing n, little n, which is 10, subtracting 1, which is 9, and it happens twice. There's 2 levels. That's yeah. So the same.
You're just doing two groups.
Well, yeah, there's 2 groups, yeah, and there's two levels of test, right? Same sort of thing you're doing here. If you look at this one, a little more complicated, which is Ri minus 1 times n minus 1 times test. So there's 2 times 9, right, times 2.
Okay, so if there's only one group and you tested them in both levels of test, then would you only take...
And if you tested them in both levels of test, then they wouldn't be nested within test, would they?
Okay.
Right? Because that would be a repeated measures factor.
Right.
They're only nested, they're nested within between subject variables. They have to be. All right. Between subjects within. You should say this to yourself 5 times before you go to sleep, every night. And then you do the interactions. See what I did there, right? It was like RI within, or RI, subjects, or sorry, test, subjects within test, RI by test, RI by subjects within test, right? You do interactions of each thing. You cross it with the things above it until you can't do it anymore. So that's sort of the what's the word I'm looking for? That's the procedure. Remember, you list between and subjects and within, and the between, and then all between factors, any interactions you can do, then the subjects, any interactions of the subjects, and the withins, then you're done. This always works. The error terms, just look below the one below it that has subjects and that term in it. That's all you're doing. As I said, this assumes everything else is fixed and the subjects are random. And that's a safe assumption, because almost everything we do is like that. Right? Almost everything we do is like that. Okay, here's another example. Little n's going to equal 5. You like the way that came on? That's pretty cool, eh? Okay, look at this. This is not a crazy design. This is not a crazy design, and I don't think there are, unlike the other one, any mistakes here. We've got A, B, and C, so we got 3 factors. We got 2 groups, group 1 and group 2. There's 5 subjects per group. You could easily see that this could be men, women, and then have 2 different variables, B and C, affected both men and women. This is not, anything over the top. No, this is a 2 by 3, because there's 3 levels of B and 2 levels of A and 2 levels of C.
I was looking at 6.
Yeah. No, that's yeah. So you look at that. Before we go through this one, are there any between subjects variables? No. So that it's A. A's between subjects. Look, different subjects get different levels of A. So that's got to be a between factor. The within factors are B and C because every subject gets every level of B and every level of C. And tell me about subjects. Where are they? In which one?
In A.
Yes. Subjects are always nested in the between subjects factor. So we got A, we got S within A, we got B and C. We'll move this over. Between subjects within. Between is A. Within is B and C. And subjects are within A. Oh my God, look at that. Okay. This looks complicated, but when you go through it, remember A is between, B and C are within. Now that you do that, this is actually mechanical. This is the kind of thing we could train a pigeon to do this. You give me a Skinner box, 3 months, touch screen, food hopper, only grain for the pigeon, somebody's going to fill out an animal use protocol, some lab space. It's going to take a long time, but I can train a pigeon to do this. First thing you list is A, because it's between. That's where you start. Then you go subjects within A, because there's no other between factors. Don't worry about that. I used to do these. I remember doing these back when I was in school, back when I was young. And I didn't do the degrees of freedom first, at the same time. I used to just do the source of variations, then go back to the DF. But you can, whatever works for you. But I would do the source of variations first, just to get that done. Because it's the hard part, frankly. A, S within A. Are there any more between subjects variables? No, so let's do the withins. I did C first. I could have done D first, but I thought I'm just a little different and wacky. Right? Little alternative. Little down the street, hip with the scene. So I went with C. Could have done B, didn't matter. C. C by A, C by S within A. Can you do C by C? No, that would be ridiculous. You know, there's a C by C interaction. No, there can't be. Well, now there's still one more between or within subject variable, B. B by A, B by S within A, B by C by C by A, B by C by S within A. Are there any more? No, we're done.
So, is that what we considered as being within?
No, it's within. It's going to be between and within. B is within. Every subject is every level of B. Every subject is every level of C. They have to be within subject factors. Now, different subjects have different levels of A. Now, the degrees of freedom. Well, A minus 1, 1. N minus 1, little n was 5, minus 1 is 4, times 2 is 8. There were two levels of C. 1, C minus 1, A minus 1, 1. C minus 1, N minus 1 times A, 8. B minus 1, 2. 2, 16. 2, 2, 16. Now, we know if there are 5 observations in each cell, right? There's 5 observations in each cell. Because N minus 1 is, or N is 5. And how many cells do we have there? It's 12, is it not? 12 times 5 is 60. That means in total there are 59 degrees of freedom. Right? So let's add this up. It's unlikely this is going to add up to the correct number of degrees of freedom if you did one of these wrong. Like if you did, the chance of this adding up properly to the right number of degrees of freedom is unlikely. It happens. One of these 9, 10, 11, 19, 21, 23, 39, 40, 41, 42, 43, 59. We did it right. And the crowd goes wild. Yay! They're doing the wave. They think it's 1984. The wave embarrasses me, by the way. Ever been at a hockey game or something? People are doing the wave. I won't do it. I find it embarrassing. It's kind of like a Nuremberg rally. They're all doing something at once. It's a little bit much for me. It's a little disturbing. Now, what do we test with what? Well, look below and find the thing that has the factor you're interested in and subject. Well, you're going to test this with this, these two with that, these two with that, and these two with that. Everybody okay? You see what I did there?
I don't, this may sound like a really big
No, that's fine.
But why do you do CSA twice?
Why are you testing with C by S within A?
Yeah, twice.
Well, you're going to test this C, you're going to test C by A.
Oh, okay.
Yeah, so you're going to test both these with this.
Why do you need to test them?
Because you have to find out if there's a significant effect of C or a significant C by A interaction.
But you,
These two both have the same error term.
okay.
These two have the same error term, and these two have the same error term.
But wouldn't you get identical because they're written out the exact same way?
No, because this the mean squared for C is going to be a different number when it comes out than the mean squared for C by A. Right? The mean squared for C by S within A will be the same. Sure.
Is this just like isolating it to see if there's any effect?
Yeah, or interaction. You're doing it. This is how you would do the F test. This thing with two between one within, there are 1, 2, 3, 4, 5, 6, 7 F tests that you do. You use 7 different F tests in this analysis variance. Because you got to test A and C and B and AB and AC and ABC. And you do. A, B, C, AB, AC, BC, ABC. They're all there. They're all there. Other questions? Sarah, you look like you want to ask a question.
No, I think
No.
it's starting to sink in.
Oh, good. Okay. Well, the best way to make it sink in is to do another example. Ooh, here it is again with the exciting entrance animation. Okay. Well, that one's different. At first, it looks the same until you look more closely and realize the tables are turned. This guy gave a talk at the conference. His name is Alan Bond, and I always wanted to ask Alan a question and say, "Well, Mr. Bond," and I'm sure he's heard it 1,000 times, but didn't have a question to ask. I was talking to his graduate students, and apparently he hears that stuff all the time. So, though he said, "I want to ask." He's never used the tables are turned now, aren't they, Mr. Bond? And he said he's going to use that, like a lab meeting. When he asks him a question, well, the tables are turned, Mr. Bond. Just let him fun. So, what do we got here? Well, it looks very similar, right? But this time both A and B are between subjects factors. Look at it. Different subjects get different levels of B, don't they? 1 and 3 get B1, and 2 and 4, group 2 and 4, get B2. And different subjects get different levels of A. A1 has group 1 and group 2. A2 always has group 3 and group 4. So both A and B are between subjects factors. Take a look at C. Everybody gets every level of C. Right? Everybody gets every level of C. So subjects are now nested, but they're not just within A or within B, they're actually within A-B combinations. Aren't they? Right? Look at that. Because if you're in A1, B1, you're group 1. Group 2 gets A1, B2. Group 3 is A2, B1, and group 4 is A2, B2. So subjects, we can't just say they're within A or within B, they're within AB. Subjects are within AB in this case. We'll say there's 6 per group this time, just for the hell of it. Just mixing it up. And again, this is not a ridiculous kind of design. This is a very common type of design. Okay, questions so far? Makes sense that they're within AB. And that C's within. C's repeated. Okay. It's funny, see, we have A, B, C, except we changed the within and the between. Look at how much, that one's smaller. Right, it's different. So we go A, B, because they're both between subjects, big. So we go A, B, A by B. Can you do B by B? No. You stop. You talk about subjects. Subjects within A, B. C, A by C, B by C, C by A by B, C by S within AB. Done. 6 subjects per group, 12 cells, or sorry, yeah, 6 subjects per group, 12 cells, 12 times 6, 72, 71 degrees of freedom. That's our total. Big N minus 1. Let's do some degrees of freedom. A minus 1 is 1. B minus 1, 1, 1. Okay, we got N minus 1 is 5 times 2 times 2, 20. C, 2 levels, or 3 levels, so 2 degrees of freedom. 2, 2, 2, 40. Because that's 2 times 2 times 5 times 2. It's 40. 1, 2, 3, 23, 24, 25, 26, 27, 28, 29, 30, 31, 40, 71. Winner. What do we test with what? This one only has 2 error terms. Last one had like, what, 4 or something like that? This one only has 2 just because we choose between, which is within. So we've got the error term of S within AB, and that's going to test everything above it here, A, B, and A by B. And then for C by S within AB, we've got C, CA, CB, and CAB. So when we do an actual analysis of variance, we take mean squared for, say, CB and divide by mean squared for C by S within AB. Amanda, you okay?
I'm still caught up on your column. Does everything else make sense?
Good. Okay, so that's good. So all this is saying is, what are we testing the mean squared for A with? What are we dividing mean squared A by when we do the analysis of variance? What are we dividing mean squared by? Mean squared B by when we're doing the analysis of variance? What are we dividing mean squared AB by when we do the analysis of variance? Because remember we divide by, well, in this guy over here, the example from the test, we divided everything by mean squared error, which is actually mean squared for S times within AB. I don't know why I'm whispering. We call it mean squared error, but actually it's just S within AB. It's just S within AB. We do a straight ahead vanilla analysis of variance. We have treatment and error. We have treatment and subjects within treatment. That's what it is. We call it error. Does it make more sense? You see what we're doing here? We just got to do a whole bunch of F tests. And again, there's going to be 7 of them, except this time instead of having like, I think it's 3 error terms, we only have 2 or 4, whatever it was from the last one. That's what you divide by. That's all we're doing.
They're all error terms?
No, just this and that. They're what you're dividing by in the analysis of variance. Right. You know, you think back to the straight ahead analysis of variance about mean squared treatment by mean squared error. Well, here we've got the sort of 2 mean squared error, if you want to call them those, and that's this and that. We're going to get a mean squared for C by S within AB and a mean squared for S within AB. Good. Not so